and
Thank you very much.
welcome. My name is Benedicte.
My name is Emil.
And we're from Aarhus Chemistry Show. So today we're going to play a lot with fire. So of course we have some safety instructions we want to go through.
Yeah, we were wearing glasses to protect our eyes. They're not fixing themselves if they break. And we're wearing lab coats. And the lab coats are really going to be in handy for when we are going to play with fire.
Exactly. So first of all, if any of you were here yesterday, you know we played a lot with butane gas. That is lighter gas, because lighter gas, as I have here, is very, very flammable. I'm not going to do soap bubbles like most people did yesterday. Instead, I'm going to pour it into this horn, because we're going to start this show with... I'm going to get my assistant to pour the lighter gas into the horn. And then we're going to start this show properly. You see the flame? It's pretty flammable. You right? Then will you help me count, please? 3, 2, 1.
Okay, so I want to do something similar, but I want to do it a bit differently. To prepare for this, which is a kind of, well, it's a pretty dangerous experiment, but I'm preparing so as I'm safe and secure, and I have to drink this food oil, you know, the stuff you put in the pan to fry all your dinner.
The vegetable oil.
Yeah, so I'm just going to pour some in here. You see, yeah, it's good. It's really, really not tasty if you were ever in doubt about that, so.
So if in the evening you're wondering, hey, I got no more mouthwash, don't use this. It's horrible, it really doesn't clean. But what it does instead is that it fills out the pores inside the mouth. And as you see, Emil is really enjoying this. And the reason we want to do this is because the oil that Emil is going to use, which is flammable, is not very healthy to get inside your system. So by filling up the pores with this vegetable oil, he's going to make sure that nothing really enters his system, and then it's perfectly safe. But don't do this at home. All right, you ready?
Mm-hmm. Yeah.
Do you want to count down?
No.
All right, then watch and enjoy. That was our way to set the show off for a good start. Blur it up from the start.
Yikes.
You did well.
Thank you.
Okay, so we said we want to play a lot with fire, and we did here, but this was just fire, I guess you could say.
Yeah.
So what we're going to do now is we're going to mix in something else. Back in the days, when the chemists wanted to figure out which species, with which elements and compounds they were dealing with, they had different ways of testing it. So one way...
Yeah, one way was to, to taste actually the chemicals. So they put them in the mouth, and because of this we have very accurate records of the different taste of the different chemicals that we use. This tasting thing has the unfortunate downside, as Benedicte just explained, that the chemicals will enter your body, and this can be quite dangerous, and sometimes it will lead to death. So many chemists went on dying quite early because they were always tasting the chemicals.
But then new chemists came in, and they were thinking, well, if we don't taste it, we could do something else. Let's just smell it. So they went around sniffing all different kind of chemicals, and it went well at first. Because the thing is, when you smell something, it still enters your system, though it's slower. So the chemist went on to die, though it was a little later than before.
Yeah. Fortunately, some chemist was just as fond of fire as we are. So he was like, what if we burn the chemicals instead? Like, what would that do? This is a brilliant idea, because then the chemicals does not enter your body, so you will not die from that.
I think we should do that.
Yeah, I think we should do so too. So what we want is that we want a fire which last a little bit longer than what we just made. So,
in order to do so, we brought 2 chemicals. We're gonna make an ethanol gel.
Yeah.
Because ethanol, you might know that from the hand disinfectations. It burns very well, actually. So that's what I brought here.
so that's the ethanol. So for an ethanol gel, we obviously need a gel, right? This is the other chemical, the gel. This is based on a salt called calcium acetate. So what we're going to do now is we're going to mix these 1 to 10. And
as chemists, we're very precise. So I
Yeah.
got this glass with a little red line. So exactly precision.
all right, I'm ready. You ready?
Yeah.
All right. So notice these liquids, right? They're quite liquid both.
But if we mix them together, please notice what happens.
1, 2, 3.
Oh, you see that?
Wow. Yeah.
It's a solid.
Okay.
Cool.
So now we just want to light it.
Hey,
Hey.
it is flammable.
Thank you. So the chemicals we want to burn right now are salts, because salts are quite interesting to burn. Salts consist of different things, but one of the things is a metal. And metal have different colors when you burn them, depending on the metal. So we brought some here. That's not funny. We brought this one. You want to introduce that?
Unfortunately, it's very bright right now, but I hope you can see this. This is potassium chloride. That's the spaghetti salt you use back at home in the kitchen. Everyone have access to this one. Can you see the color?
It's quite orange.
It's very orange.
Oh, I went wrong here. So you see this one? This is a blue one, right? This is copper sulfate. Which color do you think this burns with? Green. Well, some of you are really smart, because that's true. You see that? So this salt is actually, well,
No, nothing.
so this is what's in rockets at New Year's, which makes them green.
Cool. I got one more. That's, that's lithium carbonate. And one used to use this in antidepressants before, because it's got this lovely red color. Exactly.
Yeah.
Color of love.
So what I got here is not a salt, it's actually pure metal. It's called magnesium. Back in the day, in the early days of photography, this was used for a splits powder. And I'm just going to try to be a bit careful with this one, because you might see, yeah, right? Okay, I'll just try from over here. Whoa, Jesus. Yeah? So you see that?
And what I got here is iron oxide, which is not as obvious, but I hope you can see it still.
You see the small sparks, right? So just yell whatever you're thinking of when we mix these two. New Year's Eve too, I can say. You see what that is? Okay, it might be a bit difficult. I don't even remember the name of them, to be honest.
The things you use at New Year's with sparkles a lot.
Yeah, sprinkles, yeah,
exactly.
thank you. All right, thank you. Very good.
Okay, so I'm gonna turn off this fire using a wet towel, and it's just like that. It turns off because this one is cold, and I shut off all the oxygen so the fire can't continue.
All right, so we want to just continue a bit here. So we brought some rocks back from home, back in Denmark. These rocks we can, when you use a hammer, you can just make them into small pieces. And these rocks are of great interest because they smell a lot, so you can use them for cleaning your garden from moles, because they smell very well too. But the thing you also can do is you can mix it with water. And when you mix it with water, it will make a gas called acetylene.
And this acetylene contains very much energy. So if we ignite that and release the energy, it can actually cause an explosion. And that's why we brought a bazooka.
All right, so we need a bit of water here. Plenty. All right, and obviously we want to make a bit of a party of it, so we brought confetti too.
Amazing. So,
You got that? Yeah, I'm gonna. Yeah.
okay, you ready?
Yep.
Like that.
Great. Bit of confetti.
And we are chemists, so of course we bought some lab rats too.
All right. So, everyone, just put your fingers in your ears because this can make some noise. All right. 3, 2, 1. Ah. Fuck. Yeah. Thank you. Thank you very much.